This is the first in a series of modules to help you learn and operate a model of legislation called pivotal politics. Pivotal politics is basically game theory plus spatial thinking plus institutional knowledge. And in this first module, we're going to talk about some basic game theory. In game theory, we talk about games. And what are games? Well, to understand a game, we need to know three things: who's playing, how they play, and how they keep score. That means the easiest way to define any game is to tell you the necessary components for that game. To have a game, you need three specific things. First, players. These are the people who play. Second, information and actions. These are what the players can do within the rules and what they know before they take these actions. And third, payoffs. What the players get when the game is done. Now, payoffs come in all forms. Sometimes people are paid in money. But at the most general level, and most of the time in political science, we think about people getting utility. Now, if you've taken a microeconomics course before, you've probably seen the word utility before. It's basically an abstract idea that tries to capture how much you like or hate something, at least relative to other things, and that relative piece is key. So if you get a utility of 12 from watching a TV show and a utility of 20 from going to a movie with friends, the numbers are pretty arbitrary. But what you do know is that you're better off going to the movie with your friends, because 20 is bigger than 12. In fact, the fact that you have a higher utility shows that you prefer going to the movies. Thinking about things in terms of utility helps us compare things, helps us figure out which you prefer. And the point of looking at the world in this way is that we can solve games. If we know this much, the players, actions, and payoffs, about a game, then usually we can figure out how the game is going to end. And that's what we're going to do with pivotal politics. But first, let's try it out on a simple example. Now, when we solve this game, a couple of quick tips. First, start at the end and work backwards. We call this backward induction. Second, remember the rules. You have to pay careful attention to the rules of the game, because what works at one point in the game might not work at another stage. So let's work through a simple game. Remember, players, actions, payoffs, start at the end and work backward, and rules matter. Suppose there are three friends, Parker, Riley, and Lorian, who are thinking about meeting up at school and then going out to dinner together. They meet up at school only if they are all going together to dinner. If they all get together, then they will vote to either get barbecue or sushi, and they will go where the majority of them choose to go. So what do we know so far? First, we know there are players. There's three: Parker, Riley, Lorian. Second, we know that they can undertake certain actions. They can meet or not meet, and they can go to barbecue or they can go to sushi. Further, we know that these actions follow a sequence. Let's start by talking about that sequence. Notice that there's two stages. First, the choice whether to get together or not. And second, if you get together, do you go to barbecue or sushi? Now at each stage, everybody has a choice between two alternatives. And we can show the choices and the sequence using a simple game tree. The sequence is also really tightly bound up with the rules. At stage one, they only get together if everybody chooses to get together. They need unanimous agreement to get together. And at stage two, they vote and go where the majority chooses. We can draw this game out in a picture like this, where the top part of the tree represents whether they get together on a unanimity rule, and the bottom part shows their options of barbecue or sushi, and they'll choose that based on a majority. So we have players, actions, and a picture of how the game is played. So what about payoffs? Well, suppose that the preferences for each player are like this. Parker likes sushi the best and prefers to stay home rather than eat barbecue. Riley and Lorian like barbecue best. But while Riley prefers sushi to staying home, Lorian would rather have a night in than eat raw fish. Remember, the two keys to game theory: start at the end and work backwards. So we'll start at the bottom of the tree. And second, the rules matter. At the second stage, the three go to the restaurant preferred by the majority. So what restaurant will they go to if they all get together? Lorian and Riley prefer barbecue to sushi, and only Parker prefers sushi. So if they get together, they will go to barbecue. At this point, congratulations are in order, because you've solved half of this game. And we can erase the bottom part of the game entirely and replace it with barbecue, because knowing the rule and the player's preferences, we know that if they get together, they go to barbecue in stage 2. So now we can tackle the top part of the tree. Here, everybody chooses between getting together and staying home. But really, we know now that if they get together, they're going to go get barbecue. So by starting at the end and thinking backwards, we really know that the choice is between staying home and getting barbecue. We need to pay attention to the rules. At the first stage, a majority isn't enough. We need everybody to get together. We need unanimity for all 3 to get together at all. And do we have unanimity? Well, let's look again at the preferences. We know that sushi isn't going to happen, so we can erase that from everybody's set of choices. Again, Riley and Lorian prefer to get barbecue, but Parker prefers to stay home to getting barbecue. So what happens? The rules say that it takes all 3 to get together, and Parker won't get together, so everybody stays home. Think about that for a second. Lorian and Riley would rather go to get sushi than stay at home. Everybody would be better off if they went to sushi. But they can't get to sushi because of the way the game is set up. Suppose the other 2 promised Parker that they would go to sushi if they got together. Nothing in the rules stops Lorian and Riley from changing their minds and voting for barbecue once Parker shows up, though. So the promise is just cheap talk, a pie crust promise, easily made and easily broken. And Parker knows this, so Parker won't show up in the first place. And since Parker won't show up, everybody stays home. And that's what you need to get about game theory for pivotal politics. Players, actions, payoffs. Start at the end of the game and work backwards, and the rules matter, not promises. Remember, talk is cheap. Try a few questions on your own and then come back for the next module.